Okay, today we're looking at complex fractions. A complex fraction is when we have fractions over fractions. So here's an example of a complex fraction. We have 1 over r plus 1 over m over r minus r over m. Okay. So in order to clean these up, it's just a simplification. In order to clean these up, we're going to multiply each term by the common denominator. So the first thing I do is figure out the common denominator, and then we're going to combine factor. If there's any combining to do, we'll group it up so we can factor it, and then we'll be able to simplify. Okay. So to begin with, the denominators that we are looking at. This right here is the denominator for the big monster complex fraction, but we're cleaning up all the individual fractions so we have no more little mini fractions. So when I talk about multiplying by the common denominator, we need to look at these denominators and multiply by the common denominator. Well, they all have r's and m's, so the common denominator is r times m. Okay, so our common denominator, I'll put common d, is rm. R times m. So that means we're going to multiply each of these. Actually, I should say this in alphabetical order. I should put this alphabetical order, m, r. So we're going to multiply each term by the common denominator of m, r. So we're going to put an m, r times each of these. Now, what you have to remember is this when you multiply. Okay? MR is times this entire fraction. So that literally means MR times 1 over R. So if you need to mentally put a 1 under here, go for it. And then you multiply straight across. But I'm not going to do multiplying straight across. I'm going to cancel first. You multiply straight across, you're just going to make you work harder for yourself. You cancel first. It's like what you did in 5th grade when you were multiplying fractions if the teacher taught it to you correctly. Notice here I can cancel these r's out. So I'm just left with 1 on the bottom and then m times 1 at the top. So r's cancel, m times 1, m. Now I have my plus sign. Same thing here. 1 over m times m over r. Notice here, the m's will cancel, so I'm just left with 1 times r. R. Okay. So on this one, what I did, 1 over m times mr. If you need to, put a 1 under there. You don't have to. And then we cancel anything on the bottom with anything on top. So I'm just left with 1 times r. All right, here, same mr times m over r. So the r's cancel, and now we're multiplying m times m squared. So it's mr times m over r. Remember, you can cancel anything with the bottom with anything on top. R's cancel. You cannot cancel those m's. They're both on top. And all we can do is multiply m times m. Okay, so we got m squared minus, and now I have my rm times mr. What cancels? That's right, the m's cancel, and we multiply the r times r. So r squared. Okay, so it's r over m times mr. If you need to, put the 1 under there. Anything on the bottom with anything on the top cancels. So I have r times r. They're both on top. You cannot cancel. You got to multiply. R squared. All right. So we did all the hard stuff. Now the easy stuff. Okay. There's nothing to combine, so I'm ready to factor. Can't factor the top, but I can factor the bottom. So I have m plus r over an m minus r and an m plus r. And now I can cancel. this MR, this quantity MR, can cancel this quantity MR. So we're left with, if everything on top cancels out, put a 1. So I have 1 over M minus R. So we just simplified this expression. All right, let's do another one. Okay, here we go, another complex fraction. All right, what's the common denominator? What's our common D? That's right, I have A's and I have a B all in the denominator. This 1 has a 1 for a denominator, I don't have to worry about it. So it's AB. So AB is the common denominator. And so we're multiplying everything, each term, by AB. So the reason why I multiply by the common denominator is to make the denominators cancel out. So what cancels here? That's right, just the A's, and then we have B times B, B squared, minus. Nothing cancels here, so I'm just left with AB. 1AB, I don't need the 1 in front. What cancels here? That's right, just the A's. So I have B times 1. B. What cancels here? Just the B's. I'm left with just a 1 times A, so minus A. All right. Now there's nothing to combine, but we're ready to factor. So the factoring right here, okay, there's no double parentheses here. This is just a GCF. GCF means you have something on the outside, well, it's only one parentheses. What do they have in common is a B, and then I have B minus A. And then this is a B minus A as well, and they can cancel. So our final answer here is just a B. So this one big giant mess of a complex fraction just reduces to B. Yay, just a B. Okay, we're moving right along. Number 3, let me scooch this up just a little bit. All right, what's our common denominator? We got x squares and x's, so the common denominator is x squared. Okay, common denominator is not x because x squared will not clean up an x. Okay, you can't cancel out an x. In other words, if I did 8 over x squared times x, this x cancels the square out, so I still have an x in the denominator. So I need something to cancel out the x squared as well, so it needs to be an x squared. So your common denominator here, common D, is x squared. Okay, so x squared will make all of these denominators cancel out. So I'm multiplying everything, each term, by x squared. Then it's just canceling. Going back to those evil days of 5th grade math and fractions. That was easy stuff. Okay? So x squared is gone, so I left with an 8. X cancels out the square, so 4x, so minus 4x. All right, here I have x squared, nothing cancels. And here my x cancels with the square, so I have 2x, so minus 2x. So we did the hard stuff. Now we do the factoring stuff. So let's see. Up here, what can I factor out? Looks like I can pull out a 4. And I have a 2 minus x. Down below, I can pull out an x, and I have an x minus 2. All right, what do you remember from last year? Okay, 2 minus x and x minus 2, how do they cancel? They're not exactly the same. Like up here, it was b minus a, b minus a. They're exactly the same. They cancel to 1s. These are written backwards. Anybody remember? That's right. They cancel to a -1. You have to put the -1 somewhere. Close your eyes. You put it somewhere. Top or the bottom, it doesn't matter. So I'll make the bottom +1, and I'll make the top a -1. Okay? So we have -4 over x. Okay? If you did not remember this, 2 minus x over x minus 2, if I take the top and I rewrite it, so I have a -x plus 2, now what I can do on the top is to factor out a -1, and I have an x minus 2. Okay? So if I do -1 times this, x minus 2, I have this, -x plus 2. So those cancel, and I'm just left with a -1. Okay? So that's a little quick reminder as to how we can just do this in our head. Okay. So here we did 3 of them. It's pretty straightforward. Multiply by the common denominator. All right. Now I have, you'll see this in the homework, a nice unique question. If you remember, you have to remember your exponent rules. So here's my question number 4. We have to remember our exponent rules now, because I mean, this is not a complex fraction in this format, but where the heck do these negative exponents come from? So our first job is to clean up these negative exponents. In order for me to clean up a negative exponent, that's right, I have to flip the variable. Okay, this has to get flipped, that has to get flipped. So y to the -1, so remember, y to the -1 is the same as 1 over y to the +1. Okay, y to the -2 is the same as 1 over y to the 2nd power. So I'm going to rewrite these now. Don't touch the 24 and the 2. Those actually stay on top. The y's go on the bottom. So you're looking at 1 plus 2 over y minus 24 over y squared. Okay, now I just have to do the same thing on the bottom. That's just bringing up those exponent rules. So I have 4 over y minus 12 over y squared. Okay. All right, you guessed it. What's our common denominator? That's right, it's a y squared. So I'm going to multiply each of these by a y squared. So 1 times y squared, nothing to cancel, y squared. This y cancels with the square, so I'm left with plus 2y. Yeah, and this y squared and this y squared cancel, so I'm left with a minus 24. Nice easy equation to factor. So I canceled that y squared, we're left with 24. All right, here, y squares are gone, is y squared times 1, then it's plus, this y cancels, plus 4y minus, you said it, 12. All right, y squares cancel. Those are nice, easy ones to factor. So what do we have? Y plus 6, y minus 4. And we have 6 and 2. Y plus 6, y minus 2. Yeah, those cancel. Y minus 4 over y minus 2. Okay. So this one, I mean, once we got to here, it was pretty easy to do. We just had to remember our exponent rules. Negative exponents, you flip the base. Negative exponent, we flip the base. Okay. So this is the first style that you're going to see in the homework. The second style that you're going to see is what I call ultra complex. These ultra complex actually look a lot messier than the ones we just saw. They look like this. Okay? When you can do these by multiplying by the common denominator, but there is a much easier way to do these big ones, these big nasty ones. Okay? And what we can do is literally when we do these, what we would do is you would do keep, change, flip. What the heck does that mean? Well, what you have to remember is this. This is a complex fraction, so I have a fraction over a fraction. So what you have to remember is this fraction bar means division. So we are literally dividing two fractions. 2x squared minus 15x plus 7 over 49 minus x squared divided by 6x cubed minus 3x squared all over x squared plus 7x. So this is what this literally means. This big, ugly, complex fraction just means a division. This fraction bar is simply a division symbol. So we're having the top fraction divided by the bottom fraction. Okay? And that's right, when we divided fractions, we kept this fraction the same. We changed division to multiplication. And we flipped the last fraction. There. And now what do? That's right, we simply factor cancel. Now we're at the stop right here where we just have to factor and then cancel. So we got a lot of factoring to do. I'm going to start up here. Okay? I'll do this two ways. I'll do it the short way, the guess and check way, and then I will do it the long way. My guess and check way is I know 2 is a prime number. So the only way to break up a prime number is to say 2x and an x. 7's prime, so the only factors of 7 are a 1 and a 7. Okay, only factors of 2 are 1 and a 2. So I have to put 1 and a 7 in a special spot so we come up with 15 in the middle. That's right, got to put 7 here and a 1 here. 2 times 7 is 14, plus the 1 is 15. Okay, the middle's negative, the last term's positive. This has to be a positive 7, so it's got to be either plus plus or minus minus. Look in the middle, minus minus. Okay, so I just factored that. If you didn't remember doing that a long time ago, okay, this is what you're looking at. Okay, this is your AC method that I talked about before. Okay, our A times C is 14, and your B value, so your A times C is a positive 14, and your B value is a negative 15. So if your A times C is positive, that means we have to add to get 15. The only way to add to get 15 is a 1 and a 14. 15's negative, so they're both negative. A negative times a negative is a positive 14. When you add those two negatives, you get your negative 15. Okay. Then, remember we wrote things out this way. We split the middle. So we have 2x squared minus 1x minus 14x plus 7. And I can do my split down the middle. So GCF here is x, and I have 2x minus 1. Here I can pull out a negative 7, and on the inside I have a 2x minus 1. So there we go, x minus 7, and 2x minus 1, 2x minus 1. Okay. All right, 49 minus x squared, there's your 7 minus x, 7 plus x. Here, GCF of x. Down here, GCF of, that's right, 3x squared. So I have 6x, oh no, 6x, I have 2x. 2x minus 1. Now I can just start canceling. And we'll get our final answer. So what can I cancel? Oh, look at this. 2x minus 1, 1. 2x minus 1, 1. 7 plus x and x plus 7 is fine. There's nothing wrong with a 7 plus x and an x plus 7. Remember, you can add in any order. But x minus 7 and 7 minus x is your -1 piece that we just talked about before. So you got to close your eyes and put your -1 somewhere. Top or bottom, it doesn't matter. And I'm going to put it on top. -1. This will be the +1. Okay. All right, now look at this. I have an x here and a 3x squared. Technically just the x squared. So this x can cancel, and this square becomes a 1. So across the top, we have a 1 times -1 and a 1, so -1. And on the bottom, we have a 1. There's a 3x and a 1, so we have -1 over 3x. And we're done. We just factored canceled. Okay. Some of you may, when we see the next one, some of you may skip this step and you'll just go right to here. Okay. You'll keep this the same, change this division to multiplication, and then flip the last fraction. So let's just do one more. So we have one more practice on it. Okay. Get you guys to write things down if you need it. Okay, here's my question number 6. Here's that last of the complex fractions, or the ultra complex that we're going to see. Okay, so like I said, I'm going to skip this step right here, and I'm going to go right to keep, change to multiplication, flip the bottom fraction. Okay, so then I can start my factoring procedures. So I'm going to keep this the same. Change to the division of multiplication, and then flip the bottom fraction. And now I can do my factoring. Okay. Here's another one of those AC techniques. Okay. So we can do it the long way. So your A times C is 3 times 10. That's your -30. It's A times C. This becomes a -30. And then I have to add, your B value is a -1. So I need factors of -30 to subtract to -1. Notice I said subtract because your A times C is negative. If your A times C is negative, that means your signs are different. So I need numbers that have different signs that you subtract and get a -1. That's right, 5 and a -6. Okay. So then that means 3x squared. I'm going to put my plus 5 first. Plus 5x minus 6x minus 10. And I'm going to go right to my GCFs. So I have my, so here's my split. So I have an x over here, and I have 3x plus 5. And then over here I'm going to pull out a -2, and I have my 3x plus 5. So now I have my 2 sets of parentheses. There's one of them. So this x minus 2 is one of the parentheses. Notice I'm going to put that right over here, so I'm all ready to go, so I don't have to rewrite things multiple times. And then I have my 3x plus 5, 3x plus 5. So there's the first, all right, and then here's the second, 3x plus 5, there. Okay, so we got that factored. Okay, let me get this paper out of the way, slide this up. All right, factoring here. All right, all I gotta do is pull out an x. That's right, pull out an x, and I have a 2 minus x. Look at that, 2 minus x, x minus 2. I think you already know what's gonna happen. All right, here I have a, looks like just a 5x cubed, so 5x cubed, and I have an x plus 1. All right, here, I am not going to do the AC on this. If you want to do the AC, you go for it, you go crazy. 2 is a prime number, okay? What are your only factors of 2? Hopefully you only say 2 and a 1, so 2x and 1x. And what are your only factors of 1? 1 and 1. And what do the signs have to be? Plus, that's right. So that's all done factoring. Okay, what can we cancel? Look at that, x plus 1, 1, 1. Nothing to cancel with 2x plus 1. Look at this, x minus 2 and a 2 minus x. That's right, we already said that. That's going to be a negative 1. I'm going to put the negative 1 at the top. I don't know, I just always like putting them at the top. And then I have an x right here and an x cubed. So this x cancels out, and this cube changes to a, that's right, 2. So that's it. So across the top, we have a negative 1, a 3x plus 5, a 5x squared. So we put the monomial term first, so we have a negative 5x squared, and then we have a 3x plus 5. Then on the bottom, all we have is a 1, a 2x plus 1, and a 1. So we just have 2x plus 1. So that was a big mess, but it simplified out nicely. Okay? And that's all we can do. All right, folks. This was our little notes on complex fractions.